see today? They talked about some of their questions, so maybe the questions that we cover right now are not like all of them, but they were able to maybe answer some in their groups already. Priyanka has one for us to go over, but here was number 30, which was an even from last night.
Bro.
Did we have any other evens?
Yeah. Why you just clump together to 2, dude?
Oh, 42 was from homework 40. Homework 43.
Yeah.
We're about to. That's the notes you guys should have ready. Number 50 is up on the screen.
Cheers. Okay.
Number 50 was one of those weird ones where they gave us clues and we had to take those clues and plug and chug. And once you plugged and chugged, even though it wasn't X, Y, Z, it was still 3 variables, 3 equations. And the nice thing is, oh, you already had one. You already had one. So they did like a whole human creative thing and said, forget it. Why don't we just plug it in, have 2 equations, 2 unknowns, and use substitution or elimination or whatever you want. So you had to take each of the 3, plug in the X, plug in the Y, and you would get 3 little equations with 3 unknowns, but that was, that made it a lot easier. Wow, not scrolling with my finger. Sorry, guys. 64. You end up with Z equaling 94 degrees, X equaling 36 degrees, and Y equaling 50 degrees. Now this one's kind of crazy because technically there was an example in the notes we didn't get to. But I kind of thought that maybe you guys would be just fine without me covering it, because what did you have to be able to do if you saw a picture like this? What makes 180? X, Y, Z. What else makes 180? Supplementary. What else makes 180? Supplementary. So what could you do?
180 minus.
Well, I was thinking, because, I mean, there's 2 unknowns, 2 unknowns, 3 unknowns. I think you would need to make 3 equations, 3 unknowns. And you could solve their system. This is the one in the book. It's a little different than that one.
Right?
Did what?
Well, no, we did just 180 minus 2 times.
Ew.
I found it easier that way.
180 minus 2x plus 7 minus y, like that?
Or no, wait, that's a different one. 180.
Oh, over here.
Yeah, 180 minus 5. 1.5z minus 100.
And then plug it in for one of the other 180s.
And then if you simplify, then you got like 1.5z equals 190. Yeah, and I just got 3 of them.
I mean, you do have human creative license, so there are different ways of doing it. Remember, I was just trying to show the system.
Yeah.
And so the system, like how you can tell the computer to solve it, would be like whatever, make 3 equations for unknowns. So Sophia, yeah, I'm not discounting someone else's creative approach. I'm just saying for the system and for us, like checking each other's work, we would have tried to go 3 unknowns and 3 equations.
How did I show you the example?
Oh, I don't know if we can solve it. It was one that we would have done yesterday, but we're not doing because I think we're okay with adding up to 180 and then solving. So if you think you're okay, maybe we'll do it. The doorknob is killing me a little bit. That was the last even.
Oh, shit, you.
Okay. So, coming back into our notes, in section 7.3, Priyanka, you had one that you wanted us to talk about in a little more depth, right? Which one was it? 39. Is there anything else besides 39 that you guys want us to look at? Okay. Now, how did your work, Alec? Sophia? Hold on. Are 39 and 43 both homework problems? Sophia seems confused.
No, 43.
Okay, so 39 and 43 were both homework problems. Now, Priyanka, how did your work measure up with everybody else's work? Uh-huh.
I mean, we got similar things.
Okay.
But the back of the book said it's wrong.
Okay. So both of you were wrong?
Yeah.
And then how about 43?
I didn't look at 43.
Okay, because 39 was off, so then you were probably a little dubious. Okay, so number 39 and 43 are super similar in that both of them have 3 unknowns and 2 equations, right, guys? Okay, if you were to follow my system, technically what you would have done is good old-fashioned, like still start off the same. In that I can multiply this guy by a 4, a negative 4. and I can do elimination. I'm going to go the quick way because today is not the teaching, today is the recapping, and you guys should already have work done. So I have negative 4x plus 4x would just be gone, right? I have positive 8y minus 0 is just positive 8y. I have negative 20z minus 1 is negative 21z equals, and I have negative 8. How does that look, Priyanka, as far as getting down to just y's and z's?
I got that.
Cool. So then, as we go ahead and solve, we don't have anything else. This is our equation 4. We have no means of getting an equation 5. So there's no way of getting z equal to a number, which is why, or when, we let z equal a. Got it. So now as we come over here, technically what we have is a stair step, a row echelon of, I just chose my first equation, because it already has x with a reading coefficient of 1. I could technically divide everything by 8 to make it reduced row echelon form. I don't know if it's necessarily tons nicer or simpler or neater. I don't know, I'm trying. That was negative 8, right? And I have y minus 21 over 8. Z equals.
The first equation is 2, huh? 8 equals 2.
Oh, thanks. I'm too distracted by how I can't use my board. Okay. So then we just need to go ahead and plug and chug back. Now, here's something that we didn't talk a lot about yesterday, how there are different ways of writing similar solutions. So since I just backed up and thinking your work, Bianca, putting an a in that spot, I think we probably would have done the same thing of 21 over 8a minus 1, right? And then we would have plugged both of those up into the top, and that would have been a little messy because we would have had to do x minus 2 times plus 5a equals 2. Nice thing is that one ends up being 21 over 4a minus 2. I'm going to plus 2, subtract the other side. The 2's actually end up canceling. I have my 5a and my minus 21 over 4. If I get fourths, that'd be 20/4. And 21 over 4, that'd be negative 1/4. I think x is equal to 1/4 a. Does that match up?
My x is wrong, but I got the same thing for y and for z. At the back of the book,
It says that it says 8a.
Yeah, the z equals 8a and y equals 21a minus 1.
And then it says that the x is 2a.
Yeah.
Why?
We got
Because they're.
Aren't we choosing this ourselves?
Yeah.
Do you see 8s that are going to be kind of nasty in a second? So if we're choosing A, you see it, Kim. If we're choosing A, we can choose it to be whatever we want it to be. Which means, what would be a lot nicer about multiplying kind of both sides by 8, but really we're not even multiplying both sides by 8 because we're getting to choose what we want Z to be. There are equivalent, there are equivalent systems that come from letting Z be something else. Because it's still going to get us the same solutions if we plug in A is 1, A is 2, A is 3, A is 1/3, A is 2/4, A is or 2/5. We're still going to get the same solutions. It's just going to happen a little bit differently because they were like, ew, gross, that's nasty. It's like, well, what if that was an 8A? Well, if that was an 8A, then this would be really nice because the 8s would go away and it would just be 21A minus 1. And then if I had an 8A times 1/4, that would be a 2A. Like, oh, they're just trying to make it prettier. Now, I need to double check real quick because this is still minus 1. Oh, yeah, it is.
Multiplied everything by 8.
Not everything. They didn't just multiply the solutions by 8. They chose the Z to have an 8 to make it a lot nicer. So they're just trying to make it look prettier. That's all.
It's just really.
But this one's, yeah, I know. I'm sorry. Because it's infinitely many, and so technically there are lots of different ways of writing the same thing. We just need the relationship between the x and y and the y and z and x to be the same, and technically this preserves the same relationship.
Mm-hmm.
But great question. And so that one probably threw you off for 43 because you're like, well, I can't even make 39 match. Oh, bummer, I just randomly zoomed out. I don't know how that happened. And changed the page. So 43, Priyanka, I'm pretty sure that you would have been on the right track, at least for a solution, if you had done it the other way, or I should say just the way that we learned in class. I can't promise it would look exactly like the back of the book, but let's make sure that you were on the right track in the sense of multiplying everything on top by 2. Right? And then doing elimination would have gotten us with 0x, 3y, 2z equals 3. And then we would have, I mean, we can't just let z equal a. That's not bad. It's not wrong. Maybe they'd make it something prettier. But I don't see any fractions that are going to make it too nasty. So maybe it's not too bad if we just do our x minus 3 halves y plus 1 half z. Remember, a calculator wouldn't be afraid of fractions. So they would always just say, whoever got typed in there, just divide everybody by it. And same thing here. Whatever ended up here, just divide everything by it. So we have 1y. Oh, 3 over 3 is just 0. I'm just working. Anybody want to go get rich and then donate smartboards or new technology?
I think we should donate no longer school to the school. We should stop homeschool.
That would be so dangerous. Not even necessarily for knowledge sake, just think culture and socialization and like your own self-image and identity. If you were never leaving your house.
I'm not saying
You were scary and you only leave for school. Anyway,
I'm literally never at my house. Like I don't spend any time at my house.
But imagine if you didn't.
Then
Now, you have other support networks, I think, with your family and other
Yeah.
things, right? But not everybody does. Coming back. Not that I'm judging homeschoolers. Some can do it well.
I mean, there's some
My best friends are
Most of them
homeschooled.
Well, no, Jessica has like.
But some,
they all
yeah.
have like anxiety.
Yeah.
And like
Okay, come back. Not for everybody. So Priyanka, I think we're good, yeah? Then we can just plug in a, so we have negative 2/3 a, and then we can plug in.
Yeah, I got that part, and then I got.
But now it's good. Yeah. Just finish solving. You got it. Just go carefully with those fractions.
Wait,
Is that
is it
cool?
period?
And if you don't like it, I mean, you could technically make it 3a, make it prettier. Right? I don't know if 3a would, maybe 6a, because 6a would get rid of him and get rid of him and him. Maybe 6a. If you want to make it prettier.
We're looking for 2y plus 2z.
Oh, I'm not showing all my work, but I multiplied equation 1 by 2 to do elimination with equation 2. So I added these two together after I distributed everything by 2.
So you just did all that in your head.
Yeah, because it's checking homework, so.
Okay.
Does that make sense?
Yeah.
So then coming back to notes, partial fractions. Oh, there's another one? Yeah.
47. This is bruh. It was just a bruh.
Yeah, I know.
There comes a point you have to stop drinking coffee and start eating food.
It's not safe.
No.
You go run on my hand.
Jaden, go get some water.
Is that what it is?
Yeah,
Okay.
hydrate.
Oh my
Well,
God.
because coffee dehydrates.
Okay. It should be like, isn't there water in coffee?
Jaden, are you okay?
I don't know. I don't feel good.
It's 4 cups. No, it's like 5.
I think
my
it's
coffee
here.
was icy. I wouldn't have
A
known.
couple cups earlier too.
Yeah.
Oh my god.
Oh my god.
It's like.
Well, if you don't have a lot of food on your stomach, coffee can make you feel.
Oh yeah, it makes you feel really full.
This one, Alec, was the one that I showed in class about how we have T's and S's, like X's and Y's that we plug in.
Yeah.
I don't like, well, I do, because I know the physics, but these little zeros don't really add anything or subtract anything from the meaning for you guys, so you can kind of just ignore them to make it easier on yourself. And when you go plugging and chugging stuff, like if I plug in this one, I know that this one will equal, I'm moving this guy to the other side because we're used to variable number, right? If I plug in 1 squared is 1, I'm going to end up with 1/2 a plus 1z plus s. My variables aren't going to be x, y, z, but a, v, s. But otherwise, it's really just systems of equations. I just need to keep plugging in to
So
get
you're
there.
gonna have 3 of them.
Yeah, this one's going to equal 80. See it? And then I'm going to have my system. Now I'm going to have to plug in like 2. 2 squared is 4. 4 over 2 is 2.
I think that's a little better.
Huh?
I had some nutrition. Yeah.
Okay. If I plug in 2 times v, you ever drink too much coffee, something with bread. Bread kind of absorbs. I'm plugging in, oh, S2 stays the same. So 4 over 2 is 2, and then 2 is negative. And then we have 3 squared is 9, so we have 9 halves A. Now, Alec, I'm going to stop just because at this point, oops, I plugged in the wrong side. I didn't see my 80.
No, it's next week.
Marco, what he said.
Where's Leo? I said it was this Friday.
All you need to do is solve your system.
Okay.
Does that make sense? So if you want to pretend like it's X, Y, Z.
Can we replace it with X, Y, Z?
Just realize when you get X, you're solving for acceleration. When you get Y, you're solving for velocity.
I think it's because of like the five. We skipped that.
And if you don't like me, I wouldn't like that, right?
Yeah.
You can multiply everything by 2.
Okay.
And then that's going to multiply everything by 2.
Has it ever been 7 weeks?
It depends on the semesters and how it breaks up. First semester was shorter than normal. It's usually 6, but
Yeah, people said that second semester's like a month longer.
it's a little bit longer.
Really?
I don't think it's much.
I'll let you know that we have Monday off, so then that homework will be due Tuesday.
Right.
Oh, he's not wrong.
Dude, why is my brain like?
Because you had coffee.
I have extra like superpowers.
Okay, guys, I love you guys, but we have to actually get into section 7.4. So thank you for your questions. I hope group work was able to narrow it down a little bit. I'm a little skeptical, but I think at least some collaboration happened. Like Priyanka, thank you for being like, oh yeah, they got something similar, but back to the book. Homework 43, 44, we have to move on to section 7.4. And what have I asked you to do?
Write it down.
T-proof. What about T-proof?
Tell them.
Make sure that's equal.
How do you make sure that's equal? Sophia, do you have any ideas?
You multiply the, or I still have the right.
Lord have mercy, the monster's back.
I would start on the right side also. So when you start on the right side, what'd you get? Or what'd you do? Yeah, I would agree. Starting on the left side, you're kind of like, I don't know how to undo something that's been put together. But on the right side, I know how to put together something that can't. Common denominators. So you would have gone ahead, hopefully, and just gotten this 2 over x minus 3. Plus negative 1 over x plus 2. And hopefully even from our trig work, you guys are like, oh yeah, common denominators. I know that this doesn't have trig, but I mean, I need the other guy, right? And when I multiply, what do you end up getting in the... Are we okay? Oh, Sophia, just wait, Sophia. Oh, in the backpack. Okay, go ahead.
2x plus 4
Good.
plus.
We have 2x plus 4 minus x plus 3 all over x minus 3 times x plus 2. Oh, wait a minute. Hold on. What if we had tried to start on the other side? I know in T-proofs it was like just pick a side and just make it work, but technically this section is actually about going backwards from common denominators that have been gotten. Give me 1 second, but good. I want to hear it out. Taking something that's been put together and breaking it apart. Okay, Alec, what was your idea?
We could have done the x method for x squared minus x.
Yeah, you think about factoring, right? So if we had started on this side, like maybe we could have actually thought of that denominator and been like, wait a minute. I think the factoring would help. So does this end up being x minus 3 times x plus 2? My computer was unhappy, so I was waiting for the comment. So, okay, over here, I can put in common denominators and I can bring it all together and say, over here, I could have taken my denominator and split it apart. So what would I have done next? Let's keep going on the right side. Maybe the left side isn't a good idea after all. So on the right side, you guys would have combined like terms and multiplied, yeah? X squared minus x minus 2. We just talked about how this, minus 2, minus 6, 2 times 3. We talked about how that guy factored, so therefore this guy multiplies. And up top, don't you have to get x plus 7?
Yep. Easy.
Okay, so what was using? The right-hand side. But what is this section all about? The left-hand side. How do we keep going from there? How do we keep going from there? Now, I'm going to show you an application that you don't know how to do. Something way beyond you. So I'm going to show you an application of a problem that is impossible to solve without answering that question. And then show you what is possible to solve. And I'm going to show you just a little baby peek at calculus, just a little baby one. And it's one that's actually very helpful and useful to Calc right now, and has been or was to Calc BC in like chapter 7. I'm going to show you an application, but once again, do you realize what I'm saying we need to figure out? Did you know how to do the right-hand side?
Yeah.
Two separate fractions, get them together. Two, ready? Partial fractions, getting them put together to a single rational function. What does the left-hand side need to happen in order to make it match? Somehow breaking it up. Now, we were able to factor the denominator, but how do you take to get 2 and -1? Like, okay, you could probably be like, okay, we need one of them for him and one of them for him, but how do we get those guys? That's the question. Let me show you the quick application. In calculus, there are these things called integrals. Nope, it's actually a big old S. For summa, and in Latin, summa meant addition, and addition is an infinite addition is the basis of what this guy is. But anyway, if we were to take the function that you guys just had, and that function was it x plus 7? All over x squared minus x minus 6. They could be given this problem in like Calc 1, they're just working through, getting pretty close to being able to do this one. Calc BC, they should totally know already. They could be given this problem, and the direction would be what's called anti-derive, or take the integral or integrate. But here's the problem. This guy, who's inside the problem, inside the integral, is impossible to integrate as it's written. Is impossible to integrate as it's written. Now, there are a couple different options they have as to how to tackle it, but one of the easiest is to break it up into partial fractions. What's the title of your 7-4? Partial fractions. Now, what's nice in calculus is that for the AP exam, I already know, because others have already told me, including those that have like created the test or are on the board that creates the test for the entire nation, even bigger than that, for the whole international community of people who take the AP calculus exam, that they're only going to have to face fairly easy partial fractions that actually have a really cool trick involved. So to be honest, pretty quickly I would be able to know that x minus 3 and x plus 2 from factoring, that you guys understand, are the factors. And to get that, I would have thought of this as x plus 7. There's actually something really cool for the really easy ones that's called a thumb trick method. It's also called the Oliver Heaviside cover-up method, because he was actually quite skinny. I have a picture of him in the calculus notes. It's like, Anyway, Heaviside was his actual name, but not H-E-A-V-Y. It's H-E-A-V-I. I don't know. There is a really cool trick. So ready? What are the two numbers supposed to? Don't tell me. Just look at it. Just look at them. Don't tell me. Question. How many different vertical asymptotes do I have of this rational function? 2. I have 2 different zeros that would make it undefined, right? Okay. One zero is 3. The other 0 is -2. The thumb trick method, because most of you could cover it up with your thumb, also known as the Oliver Heaviside cover-up method, says cover a factor down there, but look and see who the 0 would be. Who's the 0? Okay, now I can't plug in 3 right now because it doesn't exist, but if I cover him up and plug in 3, not ignoring him, what's 3 plus 7? What's 3 plus 2? What's 10 over 5? Oh, it's a 2! Now, I did not show you at all the math as to why that worked. I just showed you that it worked. And in calculus, it's actually kind of cool because all of them are this basic as far as going from here to here. Because ultimately, their problem is a lot longer and they have a lot more to do. Not a lot, but some more to do. So they're going to give them the easy ones. You guys are going to see some of the harder ones too, which they could if the AP exam wasn't like timed. And they do see some of the harder ones in their homework. But let's see if you guys can do the Oliver Heaviside cover-up method, the thumb trick, to find the other one. So I'm covering this guy now. How'd you get -1, which is right? What'd you plug in? And what's -2 plus 7? And what's -2 minus 3? And what's 5 over -5?
Wait, can you go through it again?
Wait. What is?
Just do what?
How did you get?
So we're plugging in a 0. Now I haven't told you why it's true. I'm just telling you it is true. 1 second, you're covering up the green and plugging in the green 0 of 3 to every x spot, and 3 plus 7 is 10, and 3 plus 2 is 5, and getting that coefficient. The next second, you're plugging in the blue 0, covering up the blue factor, and -2 plus 7 over -2 minus 3 ends up getting you the right-hand side. Now, once again, this is a trick. There's math behind why it works, and we're going to learn that math. This is an awfully cool trick for super basic partial fractions. The super basic partial fractions are the ones such that the denominator is factorable into unique, meaning it can't be like with a squared or something when you factor them. Unique linear factors. So no like x squared plus 2 that couldn't be factored down without going imaginary. And no like x minus 3 quantity squared that would need to be rewritten a couple times. But as long as you have unique linear factors, this trick will always work.
Oh, when you cover up the x plus 2, how do you get like that it's -2 and
You always take the 0. And so thinking about factors, the zeros are when you set it equal to 0 and solve.
But on the other one, when we did 3 plus 7, we did
3 minus 3 is a 0,
Oh.
and -2 plus 2 is a 0. Does that make sense? So this one I'm plugging in the blue when I covered up the blue, and this one I'm plugging in the green when I'm covering up the green. Cool trick. Now calculus would have to take this and keep going, but they're like, oh, thank goodness, so much easier than that. For you guys, we're just trying to do this whole like, hey, there's this math behind taking something that's been put together and splitting it apart. And I'm showing you a little bit of like, hey, in the future, problems like this will come, and if you don't split it apart, it's a whole lot harder. Anyway, trick. But what's the math? Okay. Because, you know me, when big whole charts come, I try to simplify it into the most important information, right? So let me simplify it into the most important information. Whenever you are trying to do a partial fraction decomposition, now remember, not everything can be done with a trick. When you're trying to do a partial fraction, what we call decomposition, decomposing, breaking apart, breaking down, let me get my highlighter out. The very first thing you should always, always, always ask yourself, ooh, that's good for talk to a Calc AB kid today and be like, hey, Miss D said you're doing improper fractions. That was today for them. Divide if you see an improper fraction. Oh, that's way too dark, I apologize. Divide when you see an improper fraction. Now, improper fraction, hold on, I thought that was just when you had a higher number on top. That's not what we're talking about. We're talking about the degree. When the degree of the top is greater than or equal to, wait a minute, not just greater than or equal to. Okay? Greater than or equal to, which means if I have a quadratic over a quadratic, we're supposed to divide. If I have a cubic over a cubic, we're supposed to divide. Divide, division, remember this thing? We would use it for slanty asymptotes. Division, remember that thing? Throw a numerator, throw a function in. The numerator always goes in the box, the denominator is always on the outside. And then we have to do some sort of polynomial division in order to be able to solve. We're trying to go ahead and, now, hold on, wait a minute. Division is a way of breaking things down. Division is a way of breaking things down. We can break down a nasty fraction to be just like some good old-fashioned polynomial with some sort of, okay, fraction, maybe what do we call that? There's a little something left over. If it doesn't go in evenly and there's a little extra something, something. Remainder. So technically this is what is formed if we have a remainder. But that remainder is going to be easier, simpler than the original fraction. So we divide first to get rid of any polynomials we can and get a simpler fraction to break down. Wait, okay, if I have to break down a fraction, why not make it a simpler fraction first? Exactly. Okay, then divide when improper. If it's not improper, we'll forget step 1 and move to step 2. Step 2 says, okay, now it's time to go ahead and factor the denominator, which you guys saw me do, and you guys thought of kind of doing at some point. Factor the denominator until you have irreducible factors. So factor until you can't factor anymore, pretty much. Factor until you can't factor anymore. However, when you factor, there are 2 different types of factors that can occur. You can get linear factors, or technically you could possibly get quadratic factors. I mean, it is possible to get higher factors like cubics or quartics that can't break down anymore, but you're not really going to face them. You're not really going to face them. And so then tomorrow what we're going to pick up is, okay, well, what do we do if they're linear? What do we do if they're quadratic? Maybe you have all these, maybe all those, maybe some of each. And how do we do the math that's behind the trick so that we can solve it even if it's not one of these easy basic ones where the trick works? But the nice thing is you guys have the trick. Not that you could necessarily really start homework. I wouldn't advise that you do that, which is nice because it's a Wednesday and there's a playoff game and some of you guys had church, so I wouldn't advise tackling homework tonight. I would say instead get caught up and do your other classes. Sound good? We have the weekend.
I got a playoff game.
You want us to go support a playoff game?
I need to sleep. I
have small group tonight, so I can't. I feel kind of bad. I'd like to.
got home at like 10:30. But I'm only working like 2 or 3 days a week, which is good.
Sometimes 3 though?
Yeah. And I'm just trying to figure something out. Yeah.
You have to use your weekend.
Yeah. Well, and then also I got a car, which is yeah. So I can drive there. But it's still in the shop because like there's a problem with the brakes. I had to get out. Yeah, it's kind of a big deal.
Yeah.
Alright, I'll see
See you later. Bye, Claire, if you're still listening.